Morning, I'm Siva Prajam. Today's topic is Laplace transformation and its application in analog communication. Laplace is a powerful mathematical tool used to analog communication. It is allowed to analyze complex signal and systems in frequency domain and making it essential component in modern communication system. In this presentation, we will explore the concept of Laplace transformations, its properties, and its practical application in analog communication. We will also discuss the advantages and limitations. Laplace is a mathematical tool used to transform time domain signal into frequency domain signal. Definition of Laplace transforms. Suppose that f is a real and complex value functions, time t greater than 0, and S is a real and complex domain parameter. We'll define the Laplace transformation f as limit 0 tends to infinity e to the power minus st f t dt. The properties of Laplace transformations. The linearity properties. Their linearity properties, it is a1 f1 e2 f2 then Laplace if e1 f1 plus a1 f2. Scaling property. If f 80, then 1 by a if is a. Time shifting property. Frequency shifting property. Time differentiation property. Time integration property. Frequency differentiation property. Frequency integration property. Time periodication properties in iterable value, final value, and conversion properties. Some uh, some properties are also there. If t, then t equals and if t equals to 1, then f is summa 1 by s. If t summa t to the power n, then in factorial by s n plus 1. If root over t, then root over by 2 is to the power 3 by 2. If t equals to sine 80, then f is summon a by sine. F is summon a by a square plus a square. If ft summon t sine 80, then f is summon 2a is by a square a whole square. If t summon cos 80, then is by a square a square. Here sin 80 equals to a by a square and cos 80 summon is by a square a square a square. The some important properties are e to the power 80 summon 1 by is minus a are also. Now we prove these properties. Let if t equals to 1, then at first the condition is t greater than equals to 0. In Laplace, we apply Laplace here. Here then if is equals to integration 0 to infinity e to the power minus st dt. Him then limit a tends to 0, integration 0 to e to the power minus st dt. When we evaluate the integration, then limit a tends to infinity, it minus e to the power minus st by s a to 0. Here a here a tends to infinity, then e to the power infinity means once 1 by a, and here now value is minus 0, then this is e to the power 0, e to the power 0 means 0, then e to the power 0 means 0, and this portion is 0, then only 1 by a s is remain. The answer is 1 by s. The second example, if limit if t equals to t, again t greater than 0, this is the condition. Now we apply the Laplace here, integration 0 to infinity e to the power minus s t t dt. We will evaluate this equation, then we get limit e tends to the infinity 1 by square minus e to the power minus a s by a square is a plus 1. Now at first we put a, then 0. Then when we here put a is 0, then this portion is 0, though the answer is 1 by s square. Let if t equals to e to the power e to the power 80, t greater than equals to 0. When we apply the Laplace there, then the integration 0 to infinity e to the power minus st to the power e to the minus st dt আর এখানে e to the power 80, then there is comes e to the power 80. There we common e to the power e to the power minus t common, and we get s minus a here. We will evaluate this, and we get 1 by s minus a. Now we prove how to sine and cos. For sine and cos, function of t equals to sine 80. T is greater equals to 0 by the conditions. The Laplace will we will work Laplace on there. Then if s equals to integration 0 to infinity e to the power minus s sine 80 dt. Then we evaluate these solutions and get if s equals to a by sine square plus a square plus a square. Here is greater equals to 0. Now I will be put last here if t equals to t to the power n. Now here will be used bypass law. So if integrations a to b ut v dash t dt. We ut means t to the power n, vt e to the power minus stdt, a equals to 0 and b equals to infinity. We will put here all of them and we get in is limit in by is limit t to the power minus 1. Again we circle this work and we'll at last we get f is equals to n factorial by s to the power n plus 1. Now will comes from inverse Laplace. In the order apply to Laplace transformation is physical problems. It is necessary to invoke the inverse transformations limit if t equals to fs. The inverse Laplace transformations do not act like this. Now we will discuss several applications of Laplace transformation in analog communications. At first, we will be see this so that Laplace transformations, principles, and properties. How to this works. Now will be serious that their application in analog communications. Laplace transformations find extensive applications in analyzed analog communication systems. It is provides powerful mathematical tools to study to behavior and characteristics of such a system in frequency domain. Here are some specialized applications of the Laplace transformation and analyze the analog communication systems. At first, we will the applications showing that system module. Analog communication system evaluate various components such as filters, amplifiers, mixtures, and modulation. The Laplace transformation is allowed to engineers to model their components mathematically and analyze their component frequency domain. By the transformation, systems defines the equation into the Laplace domain and can obtain the transforms frequency, which response systems frequency response characteristics. Now we'll be the frequency response analysis. Laplace to enable analyze to frequency response of analog communication systems by detailing Laplace transformations of systems in impulse response systems transformations frequency can be obtained. The transfer functions allow engineers to understand how to systems respond to different frequency provided insert into systems bandwidth, gain, and frequency responses. We will use also the Laplace transformations to filter design. Filters are critical component in analog communication systems used to serve a frequency spectrum of signal. The Laplace transform is aid to design and analysis these filters. Engineers can low-pass, high-pass, bandpass, bandstop filters in Laplace domains. Com- signal processing. Signal processing is fundamental in analog communication systems, particularly noise reducing, interfering removal. The Laplace transform used to design signal processing technique such as analytical and mechanical filtering. Stability analysis. Stability is the critical aspect of analog communication systems are ensured to reliable and the distortions free signal transformations. The Laplace transformations particulates the analysis stability in control system used to signal modulation and demodulation. Engineers can systems reveal the analyzed the polar and zero transformations functions and layer plus two. Feedback control. Feedback control is commonly used to analog communications to maintain stability and accuracy. The Laplace transformations is plays the critical role to analyze and design such control system involving engineering and engineers demonstrate closed loops systems perfect and reliable. Now we now the advantage of Laplace transformations. One of the key advantages of the Laplace transformation in analog communications it is a ability to specify the complex mathematical equations to allow engineers and scientists to easily analyze and design communication systems, leading the more effective and effective solutions. Another advantage the Laplace is the provide to an unific approach to analyze the both continued time and discrete time system, continuous time and discrete time system. This make is uh, it a tool to wide range of application in analog communications. The limitations of Laplace is the one of the limitations of Laplace transformation since in analog communication is it is assume linearity and time inversion, which is the not always the true the real world real world scenarios. For the example, a nonlinear circuit or time variant signal is not produced accurate result when analyzed using Laplace transformations. Another limitation is the Laplace transformation is required a complex variable analyzed which can be difficult and time consuming for complex system. Additionally, Laplace transformations may be not suitable for analyze signal high frequency component, and it is assumed stable in with finite energy. At the last We will learn that Laplace transformation is powerful mathematical tools used in analog communication. It is allowed to analyze complex signal and systems in the frequency domain, which is essential for design and troubleshooting shooting communications systems. We will discuss the properties Laplace transformations, including linearity, time shifting, and frequency shifting. We'll also explore the concept inverse Laplace. It is important in the analog communications. Will show how the Laplace transformations is frequency component, and how to design filters and amperes for for analog communications.